right, we're going to continue graphing some quadratic equations today, talking about domain and range. So just a reminder from yesterday, how to find the vertex. If you don't have an x, you don't have any parentheses, I just have an x squared and a number, or even if I'm multiplying like by -1 here, nothing is shifting this graph left or right. The vertex here just going to be 0 for your x coordinate, 5 for your y coordinate. Over here, 2 is being multiplied here. I don't have a term with an x. I don't have any parentheses. That x coordinate is going to be 0. The y coordinate is whatever's on the end here, added or subtracted. This is going to be -5. Now, what this number out in front does affect your 1, 3, 5 pattern. So whatever's in front, you want to multiply that by 1, 3, 5. For this first problem, it's -1, -3, -5. And that's just going to cause the graph to turn upside down. Here, I'm going to take 2 and multiply by each of these. What I'm doing over here is multiplying each by -1. I'm going to multiply each of these by 2. So this is going to be 2, 6, 10. And we're going to fit as much as we can on the graph here. So for my first graph, 0, 5. And from that point on either side, over 1, down 1, over 1, down 3. And then over 1, down 5, and that should be a really good picture of my graph. Do my best to create a U shape. And over here, my vertex is 0, -5, so down here. Now, the pattern here, I'm going to go over 1, up 2, and then over 1, up 6, and this is 5 points, so that's plenty to get my graph going. I don't have enough room to go over 1, up 10, so this is plenty. And just do your best to make a U shape. It does not have to be perfect. Now, let me slide this up. We're going to focus on shifting the graphs left and right today, which we did not do yesterday. And these are all going to be in vertex form in terms of how the equation's written. So let me remind you what that looks like. Y equals a, and then in parentheses, x minus h. The parentheses are squared, plus k. Now, in that format, hk is your vertex. And it's going to be, as you look at this, it's minus h. So this works just like the absolute values did, where it's the h is going to be the opposite of what it looks like, and the k is going to be to copy whatever is outside the parentheses. So let me slide this up, sorry. There we go. Okay, so out here in front, this is just a 1, and I have x minus 2, that's squared minus 3. Now, we're not going to multiply this out or anything. I'm going to do the opposite, so that would be positive 2 and copy. Now, it's what you would plug in for x that would make that 0. That's why it's the opposite. When that would become 0, that's where you switch from one side of the U shape to the other. So that's why it's the opposite of what it looks like. So this is going to be positive 2, -3. Because I just have a 1 out in front, this pattern's just going to be your 1, 3, 5. So find your 2, find -3, and then we're going to go over 1, up 1, over 1 from there, up 3, and then from there over 1, up 5, and all those will fit on this particular graph. And just like before, we're just going to do the best we can to make a U shape. Please don't make it pointed at the bottom. That's going to be more of an absolute value. So curve the best you can. The graph next to this has a -1 out in front. That's your A value. So that's going to affect my pattern, which we'll deal with in a second. Opposite with the x, copy outside, that's your y. So my vertex there, -4, 6. Now, this -1, I'm going to multiply that by my 1, 3, 5 pattern to get the pattern for this graph. So it's just going to change it to -1, -3, -5. And I'm going to go ahead and plot, start with your vertex, -4, 6. Over 1, down 1 is all this is going to do with the negative. Over 1, down 3. Over 1, down 5. And then again, just make your U shape the best you can. And that's going to be the graph there. Okay, now this is just a general form of that vertex form that I gave you on the front, but I'm going to go through some of these and point out what you would use to help answer some questions about some graphical analysis. So the maximum or minimum value is just going to be the y-coordinate of the vertex, and it's going to be maximum or minimum depending on how the graph turns. If the graph turns upside down, it'll be a maximum. If the graph turns right side up, it'll be a minimum. And in terms of the format for, if it's in vertex form, you're just going to pick the k value to answer that. Axis of symmetry is always x equals the x-coordinate of the vertex. In this case, if you're in vertex form, it should just be x equals h, so whatever that value is. The horizontal translation moves the graph left or right, and that's going to be based on your h, so whatever that is. And then your vertical translation is going to move your parabola up or down. That's going to be based on your k. Your stretch or shrink. So this is to do with that a value that's out in front here, and that affects your pattern as well. So it depends. You have two different options. So I'm going to have you ignore if it's negative. So if it's negative, just ignore the negative. If that a value is bigger than 1, you're going to have a stretch. And that's going to make your graph more narrow. Little stretch it out, and then if your a value, remember we're going to ignore the negative if there is a negative, that just turns the graph upside down. Excuse me. If you are some number between 0 and 1, like 1/2, 1/3, 2/3, 4/5, something like that, that is going to be what we call a shrink. And a shrink is going to widen your U shape and compress the graph. Now, for your domain and range, domain for any parabola doesn't matter, turns right side up or upside down, it's going to be from negative infinity to infinity. Now, your range depends on the direction the graph turns. So, if the graph turns right side up, it's going to be the y-coordinate of the vertex, which is k, and then it goes up forever, so it points up to infinity. Now, if the graph turns upside down, this goes down forever, so we want to start our interval from negative infinity, and k will be the maximum there, so that will be the stopping point. Okay, so in example 2, we are going to graph and analyze the graph of a quadratic. So out in front here, our a value is 2, and that's going to affect our graphing pattern, but before we get to that, I'm going to identify the vertex. So opposite, this will be -1, copy, -6. The pattern, remember I just mentioned, is affected by the 2, so I'm going to take that one, I'm going to write 5 instead of 3. We're going to multiply 135 by 2. That's going to result in a pattern of 2, 6, 10. So let me come over to the graph, -1, -6. And then from there, on either side, over 1, up 2, over 1, up 6, and then over 1, up 10, we're not going to be able to fit on the graph. And we're just going to do our best to connect this with a U shape. Now, your axis of symmetry is going to split the parabola right down the middle, right in half. Has to go through the vertex. And it's always just a nice vertexal line at x equals whatever the x-coordinate of your vertex is. So that's going to be x equals -1 for this question. This graph has a minimum because it's the very bottom of the graph. So this is a minimum. When it asks you for the value, it's literally just asking what is the lowest y value on that graph. So I don't write down the point, I write down the y-coordinate of the point, which is going to be -6. And then domain for any of these, negative infinity to infinity. The range, you want to come from the bottom of the graph. So I'm not touching any part until I get to that y-coordinate there of -6. Rest of the graph goes up forever, so that's going to go up to infinity. Now, these translation questions, what I want to think about here is, what am I doing to the graph of y equals x squared, which I'm going to put on the graph just real quick so you guys can kind of see the shift that's going on here. So just if I have y equals x squared, that's just 0, 0, and then over 1, up 1, over 1, up 3, over 1, up 5 if I had some more space. So in terms of the translation, I am going for horizontal, this is left or right movement, and I am moving this to the left 1. So that's what I'm going to write down. And then the vertex actually goes left 1 and down 6. So that's your vertical translation. So down 6. And then your stretch or your shrink. Am I more narrow than the original, or am I wider than the original? If you guys look at this, this is over 1 up 2, where this one was over 1 up 1. So this is more narrow. So this is a stretch. And I can tell that by the number 2. If that a value, ignore the negative. If that a value is bigger than 1, then it's going to be a stretch. If you guys want to pause here and try this on your own, you could do that, and I'm going to go ahead and walk through that. But if you do want to try it on your own, I would pause the video and try it out. I'm going to go ahead and go through it. So for the vertex opposite copy, this is going to be positive 3, positive 7. Now, the pattern here is affected by what is out in front of the parentheses. So I've got a negative 1/2. So I'm going to do negative 1/2 times my 135. Remember, my recommendation here, please write decimals for this. It'll help you graph. So I'm going to have negative 1/2, negative 1.5, negative 2.5 as my pattern. If I come over to my graph, 3, 7. And remember, if you've got a decimal, we're just going to do our best to estimate. So I'm going to go over 1 on either side, down 1/2. From there, over 1, down 1.5. So that'll put you on a nice point. Over 1, down 1.5. Right at 1, 5, and 5, 5. And then the last little step in our pattern, over 1, down 2.5. Here, over 1, down 2.5. And just do your best to make a U shape. Axis of symmetry here is still going to go right through the very middle. It splits the parabola into 2 equal pieces. And it's always going to go through the vertex, and it's always a vertexal line. Because it goes through the vertex, it's going to match the x-coordinate of your vertex, which is 7. Now, this particular graph turns upside down, so the vertex is at the top, which is a maximum value. So this is a max. The actual value is the y-coordinate of the point, so that's just going to be 7. Domain for every single one of these goes, this goes left forever, this goes right forever, even though it points down, so it's going to go from negative infinity to infinity. The range is the trickier part. So if you approach this from the bottom, this is pointing down forever. So I want to start my range interval with negative infinity. Since that's pointing down, you want to start with the lowest possible value. This has a stopping place at the vertex, which is going to be the y-coordinate of your vertex at 7. Little bracket there because I have an actual point. Okay, and then just so you guys can see this, I'm going to graph y equals just a plain x squared so you can see the translation. So to get it to go upside down, that's flipping it over, that's going to be the negative. Now in terms of everything else, we're just going to follow the rules. So my vertex for just y equals a plain x squared to get to our transformation here, I'm going to the right, I'm going over 3. So this is right 3. Then from here, I have to go up 7 to get to that point. So translating from 0, 0, we'll go right 3, up 7 to change it to there. And then in terms of a stretch or a shrink, hopefully you guys can see that this new graph, I know it's turned upside down, but it is wider than the y equals x squared. This, ignore the negative 1/2. If this is between, ignoring the negative, 0 and 1, this is going to cause the graph to be wider, which is a shrink. So that's what you got going on in that last example.